So hello guys, let us start the live. So today we are going to start our today's problem, that is in LeetCode 2573. So find the string with LCP. So this is the problem we are going to solve. So let us start. So here, so that it is a string problem. So most string problems give a string and ask you to compute something from it. So this is the problem. So here it have different approach. So you are given an LCP matrix. So it is a table describing how the string behaves and you have to reconstruct the original string. So specifically the lexicographically smallest string consistent with the LCP matrix. So here if there is no valid string exists, so we have to return an empty string. So the problem is find the string with LCP. So it is a hard difficulty problem. So here we can solve using DP with greedy. So the solution has two clean faces. So first one is we have to assign characters greedily to build the smallest possible candidate string. So the second one is we have to verify the candidate against the LCP matrix using a DP recurrence. So if the verification is passes, we have to return the candidate. If it fails anywhere, we have to return empty. So today we built both phases from scratch and we'll explain the every line of C++ code with dry run with the sample examples. So let's also cover some what are the basic mistakes. So let's get into the problem. So here we define the LCP matrix and it is zero index string word of n lowercase English letters as an n cross n grid such that so LCP of I and j is equal to the length of longest common prefix between the substrings of word I to n minus 1. So there is nothing but I to the last character and j to the last character, j to n minus 1. So given an n cross n matrix, so it's a square matrix if it is n cross n and the matrix LCP. So we have to return the alphabetically smallest string word that corresponds to the LCP. So if it is there is no string, no such string, we have to return empty string. So a string A is lexicographically smaller than the string B of the same length. So the first question where A and B differs. So string A has letter that appears earlier than the alphabet than the corresponding letter in B. So the lexicographical means, for example, if you take AABD, so it is smaller than AACA because it is A and A. After that, here A and A both are equal. When it comes to B and C, so B is less than the C. So that time B will get the priority to the character. So here they will give the input as 2D grid. So in this 2D grid, we have to print as the output of this character. So let us see how to do that. So let's see the LCP matrix. So first, for a string in the length of n, the LCP matrix is n cross n. So this is the thing where they have given. And the prefix between the suffix of the word starting at the index I and the suffix starting at the index j. So let's take this word. So let's take A, B. In this, the indexes are 0, 1, 2, 3. So when I take I is 0, so that time we will get the first index value. So when I is 1, we'll get the second index value. When I is 3, 2, the third index, and when I is 3, the last index. So if you take I is 0, so that time you will get all the string. When I is 1, you will get these three strings. And when I is 2, you will get A and B. And for 3, it is only B. Okay, when it reaches 4 or something, we will return 0 as the output pair. So here, in the full matrix, they have given, if you see that it is 4, 0, it is 4, 0, 2, 0, and 0, 3, 0, 1, 2, 0, 2, 0, and 0, 1, 0, 1. So it is, if you note it clearly, it will be like a symmetrical word. So here, let us do that. So let's try to solve it. So for the LCP of the first element, so 0 comma 0, the first element is LCP of the two values, that is AB and AB because it starts from 0 as well as its end is 0. So here it is AB and the suffix value, so AB. Okay, so same suffix values, so the size is 4. So when you take the next element value is 0. So for 0, so that time you will get different value. So for example, it is AB and as well as the VD, the problem should have values of BAB. So it is not equals to the value of A and B. So that time the value is 0. So for the next example, it is LCP of 0 and 2. So the third element. So within this third element, you will get the value of AB, the substring, which is presented to be here. So this AB will not be matched to the same value. So here the key properties of this valid LCP matrix is that it should have a symmetry within the problem. So the next one is the diagonal of the LCP matrix. So each suffix shares itself with itself. So the third property should be the same character constraint, that if any element is greater than 0 and if the word is equals to the 0, so if the first character differs, the LCP is 0. If they are same, the LCP is at least become the value of. So for example, if you take it as like that, it is AB and AB. So both values are same. The size is 4. So here same suffix. For the next element, the value is 0. So AB. So this should not change. But if you the last three character for the 0 will be there. So BAB. So it is not equals to the same value. So we will return 0 there. When you take the next element, so AB. So here this B will be removed. So the value is AB. So now the output should be 2 because there are 2 times of this AB substring is presented within here and it is completely equals. So here this A is equals to this A and B is equals to this B, but here it is 2 times of A and 2 times of B. That time it will not occur in this value. So let's see the first example and solve it. So it is 4020 and 0301, 2020 and 0101. So we have to assign the characters greedily to get the highest possible value. So initially the iteration value of I will become 1, I is 0. So initially it is unassigned. So we have to assign the A's. Like we have to assign the character A to it. So if you check that, it is the word that is present here is initially 0. So the 0th character. It should be equals to the second character of this value. So it is 0 and it is 1 and 2. So second index. So if you see that the value is the word of 0 should be equals to the word of 2. So both characters is same because here the value of j will become 0. So the prefix and suffix values. Next, I is 1. So it is also unassigned. So we have to assign the value. So the next value after A is B. So in this current string, for 1 and 3 indexes, word of 1 and word of 3 will be the character of B. So for this index 0 and 2 is A and 1 and 3 is B. So when I becomes 2, it is already assigned. So there is no need to do that. And for the I is 3, it is B and I is 2, it is A. So we have already assigned it. So in the phase 2, we have to verify this all pairs And if it is matches exactly, we can simply return this string, or else we can return empty string. So let us see the algorithm. So the first one is greedy algorithm, first phase. So we want the lexicographically smallest string here. So this means we should assign the characters as early as possible in this alphabet. First step is we have to start with a character array of n positions. So n sized array, and it should be unassigned. Initially it should be unassigned. So next step is, so we have to iterate through the characters from A to Z. So iterate through A to Z. So next one is step 3. So in this step, so we'll see for the current character, we have to find the first unassigned position. So the character should be like A, B, C, etc. So but for lexicographically, we should look for the starting of this unassigned position. So that time it can be a very smallest element. So here, let us move on to the next step, that is step 4. So in this step 4, we have to assign the position. So for every j is greater than 8. So that time, so there are 2 pointers. So where LCP of I comma j is greater than 0, we have to assign C to the position of this j, the character to the position of j. Because if the character of I comma j is greater than 0 means the word both I and j is equals. So that time we can assign it to j. So step 5. So that is here. So we have to repeat this process until all the positions are assigned. So final step is, if any position is still assigned after 0, after z, we can return empty string. So that's all for this phase 1. So next one is phase 2. So in this phase 2, so the candidate string is produced by phase 1 may not be the LCP exactly what we want. So we have to verify it using this DP. So first we have to check the length of the longest common prefix. So the next one is, we'll use a DP array to store the values and verify it using it. So if any value is mismatching with the current DP value, we can just return the empty string. So let's try to solve this problem. So it's the approach. So let's code it here. So first let us get the size. So size of n is lcp.size. So next one is, we'll create one string and initialize all the characters to the null. So string. So let's name it as word. So we initialize all the characters to null. So next one is phase 1, the greedy part. So first one is greedy. So let's name it as greedy. So initialize the character with 0. So the current character is A. So initialize it 0 and we'll type converts it. So let us write the for loop. I 0 and I less than n and I plus 1. So if my current word, okay, my current word is equals to, if my current word is equals to A plus the value of C, that means the character where we storing, that is already A. So before that we'll check if it is not equals to 0. Because if any value is assigned, we have to skip it. So I skip it here. So the next one is, if my C is greater than or equal to 26. That means if it go out of the Z, we can return the empty string. So now we'll check that. After checking it, we can add my current character plus C, because that time it will not have any other values. So current character is equals to the character A plus C. So now we'll iterate through the second loop, that is the columns. So j is I plus 1 and j less than n and j plus plus. So so we assign the character A plus C to the position. So then every j is greater than I. That means if LCP of the current character, that is I and j, is greater than 0. So that time the next word is also the same word, that is the suffix word. So the word of j is also the word of I. Okay. So using this, we can calculate this value. After every inner loop, we'll increase the character size by 1. So A to B and C, etc. So first one is that we create a string with the length of n and initialize to the null characters. So that is the ASCII value of 0. So after that we use 0 for the unassigned sentinel. So no lowercase letter has the value 0. So we check if the current word is not equal 0 with the iteration of loop to mean that if it is unassigned. So on the end of the phase 1, all the positions will be assigned to any of the lowercase letters. So next one is the phase 1, the outer loop. So here the initial we will initialize the C with 0. So the C counts the character we are assuming and 0 means A. So 1 means B, etc. It will goes on. So for each position of I, if it is already been assigned from the previous character propagation, we skip it. Otherwise, we are upon to assign the fresh character. So using these two conditions, so next one is assigning and propagating the value. So we assign the character A plus C at the position, and if any values that is j is greater than I that time, and as well as the value is not equals to 0, it is in a positive value. The word of j must equals to the word of I. That means the both value of index will be the same character. So we only look at j greater than I, so not j less than I, because the positions from 0 to I minus 1 is already fully processed. So the incrementation C to prepare the next unique character will be easier. So the next part is the DP process. That is nothing but phase 2. Phase 2. So it is DP verification. So here let us create one DP storing array or a 2D vector. So let us create 2D vector for dynamic size. So the data type is integer. So DP of, let's still name it as DP. So the size should be n plus 1 because it is 0 indexed. So it is storing vectors, that is in a 1D array. So which is also integer. It is having the value of 1 and initialize with 0. So now, so we declare an n plus 1 and n plus 1 cross table with all zeros. So then extra row and column that the index n serves as the base case. So for the DP of n comma j and I comma n is 0. That means for all I and j, no suffix existed beyond the position. So this lets the dynamic programming to safely access through the I or j that is equals to n minus 1. So let's fill the DP with the values. So we'll form on bottom to right and top to left method to solve it. So further let us write a nested loop. So I is 0. So we are going to move from bottom to up, like that bottom to left. So that method should be started from n minus 1 and end at the topmost value, I greater than or equals to 0. So finally I minus 1. So for the next one, next follow. So this also starts from the right side corner. So j is also n minus 1. J is greater than or equals to 0. J minus 1. So if both words are same, if word of I and j both words are same, so that time we have to add the DP value and store it there. So let's store it, the DP value of I and j is 1 plus the DP value of I plus 1 and j plus 1. So this plus 1s are used for the 0 indexing value that we have previously used. So that's why we have given here. So if the words are being different, So the DP of ij will become 0. So here this is nothing but the next value. We'll add 1 plus the next value, the next diagonal value. So or else we'll just make this value as 0. So after this else case, we'll check one more condition, that if my current element in the DP, that is DP of ij, is not equals to the value of LCP in the current. So the value of LCP, we have to return an empty string. So or else we simply return the string that we have stored. So let us try to run this. So here we have to end it here. That's it. We have solved this problem. So let's submit it. So see you on the next slide.